Going to solve the CBSE class 9 matter in our surroundings in-text questions. The first question is, which of the following are matter? As we know, the definition of matter is something that occupies mass and has volume. So if we categorize the question into two parts, chair is a matter, air is also matter, love is a feeling, smell is a feeling, hate is a feeling, almonds occupy mass and have volume, so they are classified in the matter classification. Thought is a process. Cold is a feeling. Lemon water is mass. Smell again is a feeling. Give reasons for the following observation. The smell of hot sizzling food reaches you several meters away, but to get the smell from cold food, you have to go close. The answer to this is very simple, as particles of hot food have more kinetic energy. Due to being high in temperature. And hence rate of diffusion of these particles is more as compared to cold food. A diver is able to cut through water in a swimming pool. Which property of matter does this observation show? It simply shows particles of matter have space between them. What are the characteristics of the particles of matter? Particles of matter have space between them. Particles of matter are continuously moving. And particles of matter attract each other. Moving on to the next set of questions, the mass per unit volume of a substance is called density. Density equal to mass upon volume. Arrange the following in order of increasing density: air, exhaust from chimneys, honey, water, chalk, cotton, and iron. Iron is greater than chalk, is greater than honey, is greater than water, then cotton, then exhaust, and then air. Second question we have done in the previous video, so you can go and watch that video and see the differences in the characteristics of states of matter, and also the definitions of the following terms: rigidity, compressibility, fluidity, filling a gas container, shape, kinetic energy, and density. Give reasons. A gas fills completely the vessel in which it is kept. So The answer to this question is very simple. Due to high kinetic energy of particles of gas, they keep moving in all directions. A gas exerts pressure on the walls of the container due to the above reasons also, and because particles of the gas vibrate and hit the walls of the container. A wooden table should be called a solid. By the properties of solid, we know that they are rigid, they have maximum intermolecular force, their intermolecular space is very less, and compressibility is negligible. So because of these four reasons, a wooden table should be called a solid. The fourth question is, liquids generally have lower density as compared to solids, but you must have observed that ice floats on water. Find out why. Ice floats on water because it is less dense than liquid water. So that means density of ice is less than density of water. This unusual behavior is due to the molecular structure of water and the way it forms hydrogen bonds. So we can say, to explain this question, that hydrogen bonds are being formed by the molecular structure of water, and the water molecules are held by hydrogen bonds. So these bonds are constantly breaking and reforming, allowing molecules to come close together, resulting in higher density. When water freezes, the molecules arrange themselves in a hexagonal crystalline structure due to hydrogen bonding. This structure creates open spaces between molecules, making ice less dense than liquid water. The next question is, convert the following temperature to Celsius scale. The first is 300 Kelvin. We know that 0 degrees Celsius is equal to 273 Kelvin. On the RHS, we can subtract 273 Kelvin and add 300. Here also we can subtract 273 and add 300. So it becomes 300 minus 273 equal to 300 Kelvin. 300 minus 273 is 27. So 27 degree Celsius is equivalent to 300 Kelvin. Similarly, we can find out that 573 minus 273 gives 300 degree. What is the physical state of water 250 degrees Celsius? It is in gas water vapor because it is above the boiling point. 100 degrees Celsius, the water is boiling, so it exists as water as well as water vapor. The third question I have answered in the previous video, you can check that video. Suggest a method to liquefy atmospheric gases. Applying pressure and reducing temperature can liquefy the atmospheric gases.